Okie dokie. Take two. Video here is on section 6.3, proving that a quadrilateral is a parallelogram and using coordinate geometry with parallelograms. But it's not too much new stuff in this section. We're mostly kind of reviewing this. But everything that's true here, we can say the converse is true. And what do I mean by that? Well, let me give you an example. Yesterday we learned that a parallelogram's opposite sides are congruent. The converse of that is if a shape's, actually we're talking about quadrilaterals here, so if the quadrilateral's opposite sides are congruent, then it's a parallelogram. Now, statements, not all statements flip like this, but these do. Similarly, parallelograms, opposite angles are congruent. All of them. Converse is also true. If quadrilaterals, opposite angles are congruent, then it's a parallelogram. And so we can use the converses of all these things from yesterday to prove that quadrilaterals are parallelograms. And that's what we're going to do in section 6.3. Prove that a quadrilateral is a parallelogram. So with that in mind, let's look at this first example here. It says, as the sewing box below is opened, the trays are always parallel to each other. Why? Okay, so I've used some red and green coloring to sort of highlight what looks like a parallelogram in this example. Now if you look really closely at this one, and if I move the lines out of the way, you can see that not only are these, clearly these metal things are not changing, getting bigger or smaller. They're metal, so they're stuck at a fixed length. So that 2.75 sticks. You can also see that there's a little screw right here and a screw right here, so that's screwed into the wood, so that distance isn't going to change, so that's going to be 2. So this 2.75 is going to stay 2.75, this 2 is going to stay 2, and that's going to be true here, 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 and here. Which means that always, you're always going to have a quadrilateral with opposite sides congruent. And if opposite sides are congruent, then it's a parallelogram. And if it's a parallelogram, then opposite sides are parallel. So, therefore, the trays are always parallel. All right, let's move on to our next example. Now we're using properties of a parallelogram in a coordinate plane, which, like we see this objective here, use coordinate geometry with parallelograms. So, show that 2, -1, 1, 3, 6, 5, and 7, 1 are the vertices of a parallelogram. So, first thing we do is we plot those points, 2, -1, 1, 3, 6, 5, and 7, 1. And then we connect them. There's only one way to connect them to make a quadrilateral, so we do that. What do we know about a parallelogram? That opposite sides are congruent and opposite sides are parallel. That's it. Congruent and parallel. Now, they're going to show you two methods down here. And for me, one method is easier than the other. But basically, I can either, method one is show that they're parallel. And how do I show parallel in a coordinate plane? Well, parallel lines have the same slope. So what I can do is calculate the slope of each of these lines. Now, you can use slope formula, that's what they do here. 3 minus -1. Or you can just visualize it if you're more of a visual person. So the algebra is in the formula. The visual is rise over run. The rise is -4. Just count it. And the run is 1. So here the slope is -4. And then same thing here, -4/1. So same slope. And then you can check over here. What about the other parallel lines? The rise is 2. The run is 5. And that seems to be true down here as well. 1, 2, 3, 4, 5. 1, 2. And so both opposite sides have the same slope, therefore they're parallel. Both pair of opposite sides have the same slope. The other method, if you want to show congruence, would be using the distance formula. Again, here you plug in this squared plus this squared, and you get this squared, and it would work on this, 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 and this the same way. All right, that's all we've got. I told you it was a short video. I'll see you tomorrow.